Okay, welcome to day 2. We're going to do more transformation of functions. The first day we looked at transformation of functions on graphs. Today we're going to look at how we modify equations, and then you'll see on the second page how we modify tables, because tables are also functions. And then the last part we're going to look at symmetry. We're going to play a game called even, odd, or neither. Okay, so when we modify equations, again we're still looking at, here's our function with the 4 letters A, B, C, and D. A and D are on the outside, they affect the y values, and B and D are on the inside, and they affect the x values. So if we ever have something inside parentheses, that goes in for the letter x. So we're going to work this with this example where I give you a function, and first problem says 2 times this whole function. Just distribute 2x squared minus 10x plus 8. Now technically, if you would graph these two functions, the one I did in the red and the one I did in the black, that the one in black would be vertically stretched twice as big as the first function. The next one says, says subtract 2 from this function. So take the function x squared minus 5x plus 4 and subtract 2 from it, and you would get x squared minus 5x plus 2, and this one in blue would be shifted down 2 spots from the one I did originally, the one inside the red rectangle. This next problem, I have a 2x here. That means I have to put this 2x in for all these x's. So I got to put in a 2x and a 2x, and this would become 4x squared minus 10x plus 4. And this one here in green, because it's a 2x, it doesn't make the x twice as big. It horizontally compresses the graph in half, and if you graph this compared to the original one, it would be half as wide. And this last one, the same idea, except now you have this x minus 2, so I'm going to do parentheses plus 4. I'm going to put x minus 2 in for these x's, and x minus 2 squared is x minus 2, which is x squared minus 4x plus 4 minus 5x plus 10 when you distribute, plus the 4. And in the end you get x squared minus 9x plus 18. And you know from a graph that x minus 2, the opposite does, it moves it right 2, and that's what it would do. So as I move up the page, I'm going to bring this function down so you can see it. So the next one says 2 times the function minus 2. So when I do all that, I'm going to get 2 times this function minus 2, and this function is just this guy, x squared minus 5x plus 4. I get 2x squared minus 10x plus 8 minus 2, and I get 2x squared minus 10x plus 6 as my result. Same thing here. I'm going to have to plug 2x minus 2 into that function. So it equals parentheses 2x minus 2 squared minus 5 parentheses 2x minus 2 plus 4. And when I do all this, 2x minus 2, 2x minus 2, I get 4x squared minus 8x plus 4, distribute the negative 5, minus 10x plus 10 plus 4. When I clean this all up, I get 4x squared minus 18x plus 18. This says take a negative sign here, so I'm going to do the negative of the whole function. Again, this function is this, x squared minus 5x plus 4. I get negative x squared plus 5x minus 4. This negative in front would be graphically flipping it over the x-axis, and this new equation in red would be flipped upside down compared to the first one. And finally, I'm going to put in a negative x. So I have to do parentheses negative x squared minus 5 parentheses negative x plus 4. According to that original function, I get negative x squared is positive x squared plus 5x plus 4. And this equation, if that's the original graph, this one with the negative here would flip it over the y-axis, and that's exactly what it would do. So the next page, we're going to see how the letters A, B, C, and D affects this table of values. Yes, there's a big giant table. We're going to complete it all. We're going to do one row at a time. So let's see what we have to do. Well, first off, the whole idea is that this second row, the top row is x values, this second row are y values. This whole row are y values. And when we do the four letters A, B, C, and D, A and D are on the outside of the parentheses, outside the function. They change y values. That means when I have the letters A and D, I will be changing these y values that you see here, 1, negative 2, negative 7, and so on. If I have a B and a C, the B and C are inside the parentheses. They will change x values. That means these y values that I have here will stay exactly the same. What's going to happen, they do not change. They will be relocated them to a different square. They're going to change in value. They're going to change location. So the very first one, I notice I have an A value. 2 is an A value, and all it says is 2 times all the y values. So see all these y values that we have right here, all these y values, you just multiply them by 2. So if you want to write it out, you could do 2 times 1, 2 times negative 2, 2 times negative 7. I'm not going to do it. I'm going to do it mentally. 2, negative 4, negative 14, negative 6, 0, 8, and 14. Those are the new values. If you did this graphically, if you notice, all I did was change my y value. A changes the y value. Second row, I think I have the same thing. I have a D value, so I'm going to take all these y values and subtract 2. Not the one I did in blue, the original y value. So 1 minus 2, negative 2 minus 2. So I get the y values of negative 1, negative 4, negative 9, negative 5, negative 2, 2, and 5. And again, since I had an A and a D, all I did was change y value. This row here, I'm going to do in red. Oh, a negative. This is an A value. So it says take all these y values, the top, this y values here, that second row, and make them all the opposite which I had before. So 1 becomes negative 1, positive 2, positive 7, positive 3, negative 0, negative 4, and negative 7. And these change the y value. These 3 rows were very easy because all we had to do was change the y values. Now we're going to get to the harder rows. This row here, I see a letter C here, and what I need to do is I'm going to have to recalculate my x values. So I'm going to do x minus 2 to all these x values on top. So this is going to be 3 minus 2, so this is f of negative 5, f of negative 4, f of negative 3, and so on and so forth. And that means f of negative 5, well, that means I have to find a negative 5 here, and there is no negative 5, so this result would be undefined. Same thing for f of negative 4. There is no negative 4 in the x, so this is also undefined. But f of negative 3, I do have a f of negative 3, and that result is a y value of 1. Same thing, I get negative 2. Same thing, I get negative 7. Next one I get negative 3, and finally I get 0. And if you see what we've done here is that these y values, here, let me circle these y values in green. These y values, if you notice in the first 3 rows, they changed because we had an A and a D value that changed y values. But right now, these y values are exactly the same as before, except they've been moved, they've been relocated. And in fact, you know x minus 2 moves things to the right 2 on a graph, and these have been moved right 2 squares. This 1 was in this first square, and now it's been moved right to it's in the third square. Now this next row is going to be very easy because all I have to do is say, oh wow, this is the same thing. So all I have to do is this last row that I just did, subtract 3 from the y values. So undefined minus 3 is still undefined. Undefined minus 3 is -2, -5, -10, -6, and -3. And all I did was subtract 3 from these y values. This next row, I see a b value here. I'll use blue. I have a b value, and it says basically make opposite x's. So I'm going to recalculate all my x values. So instead of -3, this is going to be f of 3, f of 2, f of 1, and all the way down the line because I'm recalculating my x values by plugging in whatever x value I have. And then I notice, well, f of 3 has a value, and f of 3, that y value answer is 7. And down the row, it's going to go. And what really happens is that I reverse that top row. And by reversing it really is a flip of the y-axis, because that's what it would do graphically. Now we're getting a little bit more difficult. I think I can see everything right now. Again, I see that I have a b value, and whenever I have something inside the parentheses, I have to recalculate my x's that go with it. So when I recalculate all these x's, I get f of -6. Oop, that's a little bit sloppy. F of -6, f of -4, f of -2, f of 0, and down the row I go, taking double all the x values. Now these are not my answers. You know, some people will do this and say, well, I'll double the x and I put down -6, -4, -2, 0, 2, 4, 6, and I would say, no, you're giving me x values. Every answer in this table is a y value. Every single one. Sometimes they're changed, sometimes they're the same. The top 3 rows, they were changed y values. The next 2, they were moved to different spots, but they still were y values. So looking at all this, I'll do this in blue. F of -6, there's no -6, this is undefined. -4, still undefined. -2, that answer is -2. F of 0 is -3. F of 2, that answer is 4. And there are none of these. And if you go back, what does f of 2x do to it? It's a horizontal compression by a half of x. And these x's are half as much as they were before, because if we look carefully at the beginning of the table, -2 was 2 squares away from the center, and now -2 is only 1 square away from the center. It's been the distance from the x's have been compressed in half, and so on and so forth. So I'm going to use this. Again, I have a b value. My b value is a half, so I'm going to recalculate my x values. So I recalculated all my x values, and I realized I have to match up y values. Well, there is no -1.5 for x here, so f of -1.5 is undefined. F of -1, I do have a f of -1. That result is -7. -0.5 is undefined. F of 0 is -3. 0.5 is undefined. F of 1, I do have a result of 0, and f of 1.5 is undefined. And if 2x was a horizontal compression by half, then this is horizontal stretch by double the x. If you notice, again, we can go back to, let me put green, -7 is 1 square away from the center, and now -7 is 2 squares away from the center. X equals 0 is the center of the table. Okay, for the next row, again, I have this whole, let me grab my pointer, 2x minus 7 business. That is a b and a c value. I'm going to have to recalculate all my x's all over again. So this first x was negative 3, so that would be f of negative 10, and so on and so forth. So I recalculated all my x values, and I have all these, and at negative 10 there is no y value. At x equals negative 8, again, these are all undefined until I get to f of negative 2. And you go back to the top of the table, f of negative 2 did have a result of negative 2. F of 0 had a result of negative 3, and f of 1 had a result of 0. So f of 1 had a result of 0. No, yeah, I'm good. Okay. So, but we can even look at this more carefully. Let me grab my pointer here. That this row and this row were very similar. And if you look at this, it should only be, I'm sorry, I made a mistake. I'm going to have to change it, but I only have to go negative 4 over, so negative c over b with negative 4 over 2, which is equal to, positive 4 over 2, which would equal 2. So this would be right 2 squares, and this is where I made my mistake a little bit. Can I erase? No, I can't erase. I got to grab that. Go back to pink. If you notice, in this row, negative 2 is here, and now it's been moved right 2 squares. Now these next two rows, I'm going to use what I've done before. So for this row, I'll grab red. Well, I'll grab the blue because it's already in blue. I already have f of 2x, and I have f of 2x here. So I'm going to use this row and do 2 times that row minus 2. So this whole row in blue, I'm going to multiply by 2 and subtract 2. Negative 2 times 2 minus 2 is negative 6. Negative 6 minus 2 is negative 8. 2 times 4 is 8 minus 2 is 6. And then the rest are undefined. And again, I'm going to do the same thing here. I'll do it in black. I already have done this 2 rows above it. So I'm going to take negative 2 times that row and minus 2. Well, this one here in pink that I just did is all undefined until I get here. So I have to do negative 2 times that is 4 minus 2 is 2. Negative 2 times this is 6 minus 2 is 4. And negative 2 times this is negative 8 minus 2 is negative 10. So you don't have to start from the beginning. Finally, we're going to get to a nice easy row. This is going to be easy row. This basically says, give me the absolute value of all these y values. So I want all the y values to be positive. So these y values that you have at the very top here, I want them to all be positive. So this y value here of 1 is still 1. This y value of negative 2 is 2. Negative 7 becomes 7. Negative 3 becomes 3. 0, 4, and 7. So all these values are, all the y's are non-negative. That was an easy row. This last one is the hardest one we had to do when we did the graph. And it really is basically saying, do the absolute value of all the x's, I have to recalculate all my x's. So instead of negative 3 here, this is 3, 2, 1, 0, f of 1, f of 2, and f of 3. So the right side looks like it's going to be the same. So see these y values here on the top here on the right. So this y value of 7 is still 7. This is still 4. This is still 0. This one is still negative 3. But I had to copy them over on this side. And that's kind of what we did with the graph. We took those these x values and copy them over to the other side of the graph and didn't change these y values. So we have a nice symmetry here. So the moral of the story is if you have a and d, just change the y values by multiplying or adding. If you have a b or c value, recalculate your x and figure out what y belongs in that square for that new x value. So the last thing we're going to do is play this, what I call the even, odd, neither game. by plugging negative x into the function for x if you get the same result, exactly the same as the even function. If you get the result that is opposite, and we have to figure out what opposite means, I get odd, or if I get something that is none of the above, it is a neither function. So when we plug in negative x in for x, we have to remember that negative x raised to an even power becomes a positive x raised to an even power, and a negative x raised to an odd power becomes a negative x raised to an odd power. Okay? So let's do some examples. Very first example, I'm going to plug in negative x. F of negative x is equal to 5 negative x cubed minus 7 times negative x. I get f of negative x is equal to negative 5x cubed plus 7x when I do my arithmetic correctly, my algebra correctly. And I look at this and I say, this is opposite. So this is an odd graph. But another reason it is opposite, because if you add this function with this opposite, the sum is equal to 0. So that's another way to tell if things are opposite. 5 and negative 5 are opposite because together their sum is 0. So the next one, I'm going to do f of negative x. I get 2 times negative x over negative x squared. And I do everything correctly. And I get 2 times negative x is negative 2x, and negative x squared becomes positive x squared. And then I have to say to myself, is that the same? Is it opposite, or is it none of the above? And this is where people get confused, that technically these two guys are opposites because their sum is equal to 0. 2x over x squared plus a negative 2x over x squared. Well, the only way you can add fractions is if the denominators are the same, and the denominators are the same, and I add the numerators, I get 0. They are opposite. This is an odd function. This is where people get confused when you have algebraic fractions. Next one. Again, I'm going to plug in negative x. G of negative x becomes 2 negative x squared minus 5 times negative x plus 4. I get g of negative x is equal to negative x squared is positive x squared times 2 is that. Negative 5 times negative x becomes positive 5x plus 4. And I look at this, and I look at the original function. They're not the same. They're not opposite. This is none of the above. This is no symmetry. It's not even or it's odd. It is neither. I'm going to do the same over here. G of negative x is 5 negative x to the 4th over the square root of negative x squared plus 4. So g of negative x is equal to negative x to the 4th is x to the 4th times 5 over the square root of negative x squared becomes x squared plus 4. And when I see this, they look exactly the same. So this is an even function. This problem down here, h of negative x is negative x to the 4th plus 3 negative x squared minus 5. And h of negative x to the 4th is x to the 4th. Negative x squared is x squared times 3 is 3x squared minus 5. And I notice that these two are exactly the same as the original function. So this is again even. And then I get this last one. I do h of negative x. I get negative 7 over the square root of negative x minus 6. And I clean it up. And I get negative 7 over the square root of positive x minus 6. And I notice it is not the same as the original. It's not the opposite. It is none of the above. So my symmetry is neither. Okay, that's the even odd neither game.